When most of us hear the phrase Ice Age, our minds jump straight to Hollywood. Woolly mammoths trudging across frozen tundra, saber-toothed cats leaping out of caves, cavemen bundled in furs. The Ice Age franchise alone has planted that idea deep in American pop culture. Endless winter, glaciers everywhere, and humans struggling to survive against a frozen backdrop. But here's a twist you probably didn't expect. By the official definition of geologists, we are still living in an ice age right now. That's right. In 2025, as you sip your iced latte in Miami or jog through Central Park, you are technically inside the Quaternary Ice Age. Why? Because ice still sits year-round at both poles, Antarctica and Greenland. And that sparks a surprising question. If Earth is still in an ice age, when was the last time we weren't? When was the last time this planet was completely free of permanent ice? The answer takes us far beyond mammoths and saber-tooths. You have to rewind tens of millions of years. Back before humans, before apes, before grass even carpeted the plains. The last truly iceless Earth existed in the late Eocene epoch, between about 40 and 34 million years ago. It was a world utterly alien to ours. Crocodiles basking in Antarctica, palm trees sprouting in Alaska, whales with legs hunting in shallow seas, snakes as long as school buses sliding through warm estuaries, and giant rhino-like beasts pounding across tropical woodlands. In other words, the last time Earth had no ice, it was a land of monsters. Now, let's take a journey into that strange, scorching past and uncover what it looked like, how it worked, and why it ended. And along the way, we'll find out what this ancient heat wave has to teach us about our own future. Before we jump fully into the lost world of the Eocene, let's clear up a common misunderstanding. What exactly is an ice age? If you stop a random person on the streets of Chicago or Los Angeles and ask, when was the ice age? Chances are they'll say something like, oh, that was back when mammoths roamed the earth, right? Maybe 10 or 20,000 years ago. And they wouldn't be entirely wrong, because the last glacial maximum, when ice sheets covered most of Canada and Northern America, did peak about 20,000 years ago. But here's the trick. That was just one chapter inside a much longer story. To scientists, an ice age doesn't mean constant snowstorms or the entire Earth frozen solid. Instead, it's defined very specifically. An ice age is any period of time when large, permanent ice sheets exist in both the northern and southern hemispheres. That means ice in Greenland and ice in Antarctica. By that definition, Earth is in an ice age right now. Always has been for the past 58 million years. Span geologists call the Quaternary Ice Age. All those shifting glaciers, the Great Lakes being carved out, the woolly mammoth migrations across North America, those were just pulses within this much bigger icy chapter. We're currently living in one of the warm intermissions between glacial advances, known as an interglacial. There's also a looser definition floating around. If Earth has any permanent ice anywhere, some call that an ice age, which again puts today firmly inside the icy zone. So why does this matter? Because it sets the stage for why the late Eocene is so fascinating. To find a world with zero permanent ice, none at the poles, none in the mountains, no glaciers whatsoever, you have to travel much further back than the woolly mammoth. You have to rewind to a time closer to the dinosaurs than to us. And that shocks people. Many assume Earth has always had ice at the poles. But the truth is, ice is the exception, not the rule. For much of its history, Earth was a hot, greenhouse world. Oceans flooded continents. Warm forests spread nearly pole to pole. Life adapted not to freeze, but to heat, storms, and high seas. Here's an image that makes it real for an American audience. Imagine driving from Florida up to Maine today. You'd pass through wetlands, temperate forests, maybe some snow in winter. But in the late Eocene, that same drive would take you past mangroves, swamps full of crocodiles, and subtropical forests where palm trees shaded the road. Even Alaska would feel more like present-day Southern California. So when we ask, when was Earth last truly green, last iceless? The answer is the late Eocene, a time before the Quaternary Ice Age. a time when the map of the world looked familiar. But the climate and creatures were unlike anything we know today. And with that foundation, let's step directly into that world, a hotter planet with higher seas and coastlines that would look shocking to us now. Step out of your time machine and breathe in the air of the late Eocene. Somewhere around 40 million years ago, the first thing you'd notice? It's hot. Not blistering desert heat everywhere, but a thick, heavy warmth that wraps around you like a damp towel. On average, Earth's temperatures hovered 5 to 8 degrees Celsius hotter than today. That's nearly 10 to 15 degrees Fahrenheit. That difference might not sound massive at first. But remember, in climate terms, even 1 or 2 degrees can reshape coastlines and ecosystems. 5 to 8. That's a whole different planet. A tropicalized planet. Let's make it personal. Picture yourself in Paris. Today, you'd expect cool, sometimes chilly weather with gray skies and drizzle. But in the Eocene, Paris would have felt like Damascus or southern Texas. Subtropical trees lined the streets, and warm rains fell in heavy bursts. Across the Atlantic, in the United States, the Midwest didn't resemble prairies or cornfields yet. Instead, the landscape felt more like Uruguay or northern Argentina today, lush, warm, and green. Imagine Chicago, not with snow and icy winds off Lake Michigan, but with humid air, buzzing insects, and palm fronds swaying in the breeze. In Alaska? Forget glaciers. Forget Denali capped in white. Back then, palms grew in what's now frozen tundra. Crocodiles basked on riverbanks in polar regions, unbothered by cold that simply didn't exist. Sea levels on the rise. That warmth came at a price, sea levels. Today, about 70% of Earth's freshwater is locked in ice. During the late Eocene, with no permanent ice anywhere, all that water was free to slosh around in the oceans. The result? Sea levels soared at least 70 meters to 30 feet higher than today. What does that mean in modern American terms? Entire coastlines vanished. Florida? Gone. New Orleans? A shallow bay. The Jersey Shore? Submerged. Cities like Houston, Charleston, and Miami would be underwater. Even inland areas would be reshaped, vast wetlands stretching into what we think of as dry plains. Europe was broken into a scatter of islands. The Sahara Desert was green and wet, home to swamps and rivers. India was still drifting north, but much of it was half-drowned. Its outline different from the nation we recognize today. The weather machine. A hotter planet doesn't just sit quietly. The late Eocene climate was volatile. Warmth supercharged storms, with hurricanes spinning across oceans that reached farther inland. Droughts and floods alternated unpredictably. Massive wildfires tore through forests, leaving behind blackened scars only to be reclaimed by jungle again. For creatures alive then, stability was rare. To survive, species had to adapt to sudden swings, dry one year, deluge the next. America through Eocene eyes. Now, zoom back into America, because it's the easiest way for us to imagine. Stand on the Gulf Coast. Instead of sandy beaches and oil rigs, you'd see a broad inland sea stretching northward, swallowing much of Texas and Louisiana. Crocodiles swam where Houston traffic now snarls. Head to California. Today's coastal ranges and deserts were partly underwater. Picture Los Angeles as a lagoon dotted with mangroves, pelicans, and giant turtles instead of freeways and movie studios. Then push north. Seattle, Portland, even Vancouver were tropical rainforests, humming with insect calls and dripping with moisture. Alaska, as we said, had palms. Imagine flying into Anchorage and seeing a jungle canopy instead of ice and snow. For Americans used to the sharp contrast between seasoned snowy winters, blazing summers, the Eocene would have felt almost alien. A world with less seasonal change, more endless warmth, and coastlines constantly redrawn by rising seas. The stage for giants. This was the canvas on which life painted strange masterpieces. The warmth, the water, the forests, it all created opportunities. Large herbivores flourished. Marine predators exploded in size, and reptiles held on to power far longer than you might expect. But before we meet those monsters, take one last mental snapshot of the world itself. A green earth, flooded coastlines, storms in overdrive, crocodiles where you'd least expect them, no snow-capped mountains, no polar ice caps, no frozen lakes, just a restless, watery planet full of heat and life. Because the stage is set, now it's time to meet the creatures that ruled it. Step off the coastline of the late Eocene and wade into the water. At first glance, it might look inviting warm. Tropical seas stretching endlessly. Turquoise lagoons lapping at beaches where mangroves and palms grow thick. But don't get too comfortable, because beneath those sparkling waves, the oceans of the late Eocene were among the most dangerous ecosystems Earth has ever produced. This wasn't a sea of gentle giants. It was a sea of predators. Whales with teeth sharp enough to shred bone. Sharks that could rival modern killer whales in size. Snakes longer than school buses sliding silently through estuaries. If you jumped into these waters, you wouldn't last long. The whale that ate whales. The undisputed terror of these oceans was a whale, though not the kind we know today. Meet Basilosaurus, a sleek, elongated predator that stretched up to 60 feet long. That's about the length of a modern humpback whale. But instead of filtering plankton through baleen, Basilosaurus carried rows of razor-sharp teeth. Imagine something the size of a bus, but shaped like a torpedo, with jaws built for killing. Fossils show bite marks on smaller whales like Dorodon, suggesting that Basilosaurus actively hunted its cousins. Think about that, whales eating whales. A family feud played out across ancient oceans. And Basilosaurus wasn't just big, it was fast. Its streamlined body and powerful tail allowed it to chase prey with terrifying speed. Picture yourself as a dolphin-sized animal swimming peacefully, only to hear a rush of water and see this massive predator lunging from below. Teeth flashing. Its bite? Scientists estimate around 20,000 newtons of force strong enough to shatter concrete. The giant that didn't kill. Not every whale was built like a missile. One of the strangest discoveries of recent years is Parasitus colossus, a heavyweight champion from the same family as Basilosaurus. Instead of being long and fast, Parasitus was dense, bulky, and likely incredibly slow. Estimates suggest it may have weighed up to 50 tons or more, as heavy as several semi-trucks combined. But instead of cruising through the open ocean, Parasitus likely plodded around shallow coastal seas, its bones packed with extra density to help it stay near the seafloor. What did it eat? Probably not other whales. Instead, it might have grazed along the bottom, munching on slow, benthic creatures. In a way, Parasitus was the opposite of Basilosaurus, less predator. More gentle giant, though, with its sheer size. It didn't have to fear much. The sharks that foreshadowed Megalodon. Swimming alongside these whales were the ancestors of the most famous shark of all time, the Megalodon. Back in the Eocene, its relatives were already testing the waters of gigantism. The species Otodus auriculatus reached lengths of up to 30 feet. To put that in perspective, that's about the size of the largest killer whales alive today. Fossil teeth show they were perfectly designed for slicing through flesh, giving them a deadly edge as they prowled coastlines and open seas. And some paleontologists suggest even larger species in the Otodus family were around at the same time, pushing 40 feet. That's almost the size of a school bus, only with a mouth full of teeth and the appetite to match. These sharks weren't picky eaters. Large fish, smaller whales, even young Basilosaurus could have been on the menu. Imagine standing on a cliff in what's now Virginia or South Carolina, watching the surface of the ocean below churn as a Basilosaurus chased adoradonally for a shadow bigger than both of them to rise from the depths. The snakes of nightmares. As if whales and sharks weren't enough, the late Eocene oceans hid another monster, Palaeophis, the giant sea snake. Unlike today's sea snakes, which max out at a few feet, Palaeophis stretched as long as 40 feet. That's nearly the length of a city bus. Fossils suggest they were muscular, robust swimmers, with compressed tails that let them move like eels. They probably lurked in shallow waters and estuaries, ambushing prey. What prey? anything they could wrap around and swallow whole fish. Small sharks, and possibly even young whales. Imagine kayaking along a mangrove swamp in the late Eocene. The water ripples silently as something massive passes beneath you. Then, a head the size of a basketball breaks the surface, and coils thicker than your leg roll in the shallows. You wouldn't be sticking around long. A predator's playground. The incredible thing about the late Eocene oceans is how many apex predators coexisted. In today's seas, niches are divided. Killer whales dominate marine mammal hunting. Sharks fill other roles. And snakes are relatively small players. But back then, the waters were crowded with killers. Whales hunting whales. Sharks rivaling whales in size. Snakes longer than your car. It was a constant arms race. And survival meant staying out of the way or being fast enough to escape. And this predator-heavy world wasn't confined to one region. Fossils of Basilosaurus and Otodus have been found on every continent from the Sahara Desert, which was once a shallow sea, to the coasts of North America, Asia, and even Antarctica. No matter where you swam, danger lurked. For ocean life in the Eocene, Earth was anything but a paradise. It was more like an endless battlefield, where giants fought for dominance in warm, stormy seas. Up on land, however, an entirely different drama was playing out. The warmth and lushness of the Eocene created a stage for enormous herbivores and terrifying land predators. If the oceans were full of monsters, the continents were no less wild. And to understand that, we'll need to step back onto the shore and look around. Climb back onto the shore of the late Eocene. Shake the salt water from your hair, and look around. The land is no less alien or dangerous than the seas. If the oceans were ruled by whales with teeth and sharks the size of buses, the continents were dominated by colossal plant eaters and predators that looked like they'd stepped straight out of a nightmare. This wasn't the grassy world we know today. In fact, grass itself was still in its early stages. Instead, much of the Earth's land was covered in tropical forests, open woodlands, and wetlands. The air was thick and humid, buzzing with insects, while towering trees formed dense canopies overhead. And within these forests and plains, mammals still relatively new to the evolutionary stage after the extinction of the dinosaurs were exploding in size and diversity. The megaherbivores. Let's start with the heavyweights, the herbivores. One of the most impressive groups was the brontotheres. Imagine a rhinoceros but on steroids. These massive animals weighed up to 4 tons as heavy as an SUV and carried bizarre bony protrusions on their skulls that looked like horns fused into strange, flat shapes. Scientists believe they may have used these structures for display or combat, clashing head-to-head the way modern bison or rams do. Roaming beside them were the embryopods, relatives of elephants and manatees that also adopted the rhino body plan. Some topped 5 tons, rivaling small elephants in size. Picture a herd of these bulky, horn-faced creatures moving slowly through a subtropical woodland in what's now Nebraska or Wyoming. And speaking of elephants, though they weren't yet the towering tusked giants we know today, the early proboscideans of the Eocene were beginning to bulk up. Some were no larger than cows, but they were on their evolutionary way to becoming the mastodons and mammoths of later epochs. Together, these megaherbivores created an Eocene version of the African savanna. Imagine Yellowstone, but instead of bison and elk, you'd see strange rhino beasts with shovel-like horns, bulky proto-elephants, and herds of heavy herbivores moving through warm, forested floodplains. The primates in the trees, while the ground shook with giant herbivores. The trees above hosted another story, primates. During the Eocene, primates were incredibly diverse. More forests meant more homes for monkey-like creatures to swing through. While none had evolved into great apes yet, the stage was being set. Imagine forests from Florida up into the Dakotas alive with primate chatter. Small lemur-like species leaping from branch to branch. Ironically, primates were more diverse then than they are now. The warm, wet conditions allowed them to spread far beyond their modern tropical range. It was a time when our distant cousins were thriving. The terror birds, of course, Giant mammals weren't the only ones stomping across the land. The skies, and more importantly, the ground, belonged to the terror birds. Picture a bird taller than an NBA player, standing 10 feet high, with a hooked beak like a battle axe. These were the forest racids, flightless carnivores that ruled South America and beyond. Their long legs let them sprint after prey, while their skulls delivered bone-crushing strikes. If you saw one today, it would look like Big Bird from Sesame Street had gone rogue, traded feathers for muscle, and decided to hunt you down. For smaller mammals and reptiles of the Eocene, a terror bird bearing down meant game over. The crocs that ran. As if birds weren't enough, the reptilian dynasty wasn't finished yet. Enter the cebicids, crocodile cousins that didn't lurk in swamps but ran on land. These beasts had long legs built for sprinting, serrated teeth more like those of a dinosaur, and bodies that could reach 30 feet long. Imagine a crocodile with the agility of a cheetah. That's a cebicid. Fossils suggest they were apex predators in South America, and maybe other regions too. They could take down herbivores larger than a horse, snapping bones with their powerful jaws. For tens of millions of years after the dinosaurs disappeared, these land crocs kept reptiles in the top predator role, the mammalian killers. But mammals weren't going to let reptiles and birds hold the crown without a fight. The Eocene saw a wave of terrifying mammalian carnivores. Hyenodonts, long, wolf-like bodies with massive jaws, built for endurance hunting and crushing bones. Amphicyonids, bear dogs as the name suggests. Part bear, part dog, with bulk and bite power to match. Entelodonts, hell pigs. Imagine a pig the size of a horse with giant jaws lined with sharp teeth. They weren't true pigs, but they filled a similar niche, only much scarier. Nimmervids, known as the false saber-tooths. These were cat-like predators with elongated fangs, stalking forests the way later saber-toothed cats would. This predator lineup created constant tension. Herbivores had to stay on guard against mammals, reptiles, and birds all at once. The late Eocene was a world of giants and a world of hunters eager to take them down. An uneasy balance. The land ecosystems of the late Eocene were a rare balance of power. Mammals were rising fast, diversifying into giants and killers alike. But reptiles and birds still clung to dominance in many areas. It was one of the few times in Earth's history when mammals, reptiles, and birds all competed directly for the role of apex predator. Imagine standing in what is now Colorado. You'd see massive brontotheres browsing on trees, herds of bulky proto-elephants wading through wetlands, primates shrieking from branches overhead. Suddenly, the ground shakes as a terror bird crashes through the brush, hot on the heels of a smaller mammal. And from the side, a cebicid crocodile lunges out of cover, jaws open wide. It was chaotic. It was dangerous. It was unlike anything alive today. But this strange balance wouldn't last, because looming just over the horizon was a planetary shift, one that would reshape climates, redraw coastlines again, and bring ice back to Earth for the first time in millions of years. For millions of years, Earth cruised along in its late Eocene greenhouse mode. Warm seas lapped across continents. Forests flourished almost everywhere, and giants both on land and in the water ruled without fear of ice. But around 34 million years ago, the world flipped. It wasn't instant, like a Hollywood disaster movie, but in geologic terms, it happened fast. The planet began to cool. Forests shrank, grasslands spread, and for the first time in tens of millions of years, ice returned to Earth. So, what happened? The answer begins at the bottom of the world with Antarctica, a continent on the move. Today, Americans think of Antarctica as a frozen wasteland, endless snow, penguins waddling across ice shelves, glaciers the size of skyscrapers collapsing into the sea. But in the Eocene, Antarctica looked nothing like that. It was warm, green, and alive, covered in forests where animals thrived. The reason for the change was tectonic drift. Continents never sit still. They creep across Earth's surface like slow-motion rafts. During the late Eocene, Antarctica was sliding farther and farther south, away from Australia and South America. Eventually, This slow breakup created new ocean gateways, the birth of a current. Once Antarctica separated, water began flowing freely around it. That flow solidified into something called the Antarctic Circumpolar Current, a massive conveyor belt of cold water circling the entire continent. Think of it like a mode of icy currents, cutting Antarctica off from warm tropical waters. This was a game-changer. Warm water that once bathed Antarctica's shores was blocked. Cold water began swirling endlessly, isolating the continent and cooling it rapidly. If you want a modern American analogy, think about the Panama Canal. When the U.S. finished it in 1914, global trade changed forever because ships could suddenly reroute in ways they never had before. The Antarctic Circumpolar Current was Earth's version of Theta, new route for ocean circulation that reshaped the entire climate system. Carbon dioxide drops. But the current wasn't working alone. Around the same time, levels of carbon dioxide in the atmosphere began to fall. Scientists still debate exactly why volcanic activity slowed. Rocks pulled CO2 out of the air through chemical weathering. Plants may have played a role, but whatever the cause, the effect was clear. Less CO2 meant less greenhouse warmth to trap heat. Combine that with Antarctica's new isolation, and the results were dramatic. Snow began to stick year-round. Small glaciers grew, then merged into massive ice sheets. And once those ice sheets formed, they reflected more sunlight back into space, making Earth even colder, a feedback loop that accelerated the freeze. The first ice in ages. For the first time in tens of millions of years, permanent ice sheets spread across a continent. The era of the iceless Earth was over. This cooling didn't just affect Antarctica. Global climates shifted. Tropical forests shrank back toward the equator. New habitats opened up, dry grasslands, cooler woodlands, savannas. Animals adapted or they disappeared. For the giants of the late Eocene, brontotheres, the basilosaurid whales, many of the terror birds and land crocs, this shift spelled doom. They simply couldn't cope with the colder, drier world that followed. The transition between the Eocene and the Oligocene is now considered a minor extinction event, wiping out entire lineages. A planet rewritten. Think about that for a moment. A continent drifting south, an ocean current forming, a drop in greenhouse gases. Together, these changes rewrote the history of life on Earth. If you're an American imagining this moment, picture it like the Dust Bowl of the 1930s, but on a planetary scale. Habitats collapsed, food chains broke, and survival meant adapting fast. Those that could adjust, early elephants, rodents, smaller primates, and the ancestors of many modern species, found new opportunities in the cooler world. Those that couldn't went extinct. The stage was set for the age of grasslands, of mammoths and saber-tooths, of ice advancing and retreating in cycles that continue today. And all of it began because Antarctica drifted away, spun up a current, and froze. The cooling that hit Earth at the end of the Eocene wasn't just a shift in temperature, it was a global reshuffling of life itself. For tens of millions of years, animals had adapted to a warm, wet, iceless planet. Suddenly, that stability was gone. The world turned cooler, drier, and harsher. Forests shrank. New environments appeared. And for many of the great beasts of the Eocene, the curtain fell. The losers of the freeze. The first to go were the Basilosaurus, those whale-shaped predators that once ruled the seas. For all their speed and teeth, they couldn't survive the new, colder oceans. Their family vanished entirely, leaving no descendants. In their place, the ancestors of modern whales, the filter-feeding mysticetes and the toothed odontocetes, took over, evolving into the gentle giants and intelligent hunters we know today. On land, the brontotheres disappeared as well. These rhino-like giants, with their bone horns and heavy bodies, had thrived in humid, forested floodplains. But when the forests gave way to open grasslands, their bulk became a disadvantage. They couldn't run, couldn't adapt, and within a few million years, they were gone. The same fate struck the embryopods, those elephant-like relatives that had bulked up alongside brontotheres. Without lush forests to sustain them, they too disappeared. Even primates so diverse during the Eocene suffered. Many of the strange, lemur-like families died out as forests retreated. Only a smaller, more adaptable subset survived, setting the stage for the eventual rise of monkeys, apes, and humans. And let's not forget the reptiles. The Cebacid crocs and many of the giant snakes like Palaeophis vanished as temperatures dropped and their habitats shrank. Warmer climates had fueled their dominance. The cold stripped it away. All told, enough species disappeared during this transition that scientists now call it the Eocene-Oligocene extinction event. It wasn't as catastrophic as the asteroid strike that ended the dinosaurs, but it was a decisive turning point, wiping away entire dynasties and opening space for new ones. The survivors. But extinction is never the whole story. In every crisis, some groups endure, and often they thrive in the new conditions. Among the winners were the early elephants, the proboscideans. Though many of their relatives vanished, some adapted to the cooler, drier landscapes. Over time, they evolved into the mastodons and mammoths that would later roam North America, and eventually into the elephants we know today. Rodents also flourished. Their small size, rapid reproduction, and flexibility gave them an edge. As forests gave way to grasslands, rodents spread and diversified, becoming one of the most successful groups of mammals on Earth. Carnivores shifted too. While some of the great predators of the Eocene disappeared, new groups rose. The ancestors of modern dogs and cats began carving out niches, learning to hunt in open environments where speed mattered as much as strength. The age of the ambush predator gave way to the age of the pursuit hunter. And then there were the birds. While some terror birds died out, others persisted, especially in South America, where they remained apex predators for millions of years more. Their survival shows just how versatile this group could be. Adapting to the cold. Survival often came down to adaptation. In a warmer world, the advantage went to sheer size and brute strength. In a colder world, it went to flexibility. Animals began to evolve thicker fur, seasonal breeding patterns, hibernation strategies, and long-distance migrations. Think of it like the American frontier. In times of plenty, the biggest ranch with the most cattle might dominate. But when droughts hit, it was often the smaller, more adaptable homesteads that survived. The late Eocene's giants were the ranch barons. The survivors were the scrappy settlers. The stage for the future. This reshuffling set the stage for everything that followed. Grasslands spread, paving the way for horses, antelopes, and bison. Predators adapted to chase them across open plains, eventually giving rise to wolves, lions, and cheetahs. The age of reptiles ruling the land was finally over. The age of mammals had truly begun. For us humans, this moment mattered too. Without the cooling of the late Eocene, primates might never have been pressured to adapt, diversify, and eventually evolve into apes and humans. The extinction of so many other lineages cleared ecological space, opening pathways that eventually led to us, winners and losers. So, when you think about the end of the Eocene, picture it as a massive talent show with the judges suddenly changing the rules. The giants of yesterday, the Basilosaurus, the brontotheres, the land crocs, were incredible performers. But when the spotlight shifted, they couldn't keep up. The smaller, quicker, more adaptable players stole the show. And that's a lesson worth remembering today. Survival isn't always about being the biggest or the fiercest. Sometimes, it's about being flexible, about adjusting to change when the world tilts under your feet. But this raises an even bigger question. What about the future? If Earth shifted from warmth to ice once before, could it shift back again? And if so, what would an iceless Earth of tomorrow look like? That's where we turn next. The story of the late Eocene isn't just ancient history. It's a mirror, a reminder that Earth's climate has swung wildly before, reshaping life again and again. And as we look toward the future, the lessons from that last iceless Earth hit closer to home than you might expect. Still living in an ice age. Here's the first twist. As we said earlier, we are still technically in an ice age today. The Quaternary Ice Age began 58 million years ago and continues right now. The glaciers may have retreated from Chicago and carved out the Great Lakes long ago. But Greenland and Antarctica still hold massive ice sheets. We're living in an interglacial warmer pause inside a longer icy cycle. Think of it like halftime in a football game. The score isn't final. The game isn't over. If nature were left to its own devices, the pattern of cooling and warming would continue for millions of years more. Could ice disappear again? So when will Earth go iceless again? Geologists believe it might take tens of millions of years. Why? Because the position of the continents hasn't changed enough. Antarctica is still parked squarely over the South Pole, locked inside its freezing moat of currents. Until it drifts north again, the ice isn't going anywhere on its own. Some models suggest it could be 50 million years before the poles are warm enough to melt fully. That's longer than humans have existed as a species. Longer than the gap between us and the last dinosaurs. In other words, by natural cycles alone, we're stuck with ice for the foreseeable future. But humans change the game. Of course, there's a catch. Humans aren't natural cycles. By burning fossil fuels and pumping carbon dioxide into the atmosphere, we're cranking up the global thermostat in ways unseen since the Eocene. Think about Miami, New Orleans, New York City. These American icons already sit at the edge of rising seas. If we keep pushing CO2 higher, we risk nudging Earth back toward an Eocene-like state, hotter temperatures, higher seas, unpredictable storms. The Eocene tells us exactly what that looks like. Palm trees in Alaska, crocodiles in the Arctic, sea levels 200 feet higher. Cities like Boston and Los Angeles would be underwater. The Gulf Coast would vanish. Even the heartland would see new inland seas. It wouldn't happen overnight. It might take centuries or millennia, but once the ice is gone, rebuilding it would take millions of years. Winners and losers. Round 2. And just like in the late Eocene, there would be winners and losers. Species that can adapt. Small, fast reproducing animals might thrive. Larger, slower creatures could vanish. Coral reefs might bleach away, while jellyfish populations explode. And humanity? Our technology gives us advantages the brontotheres never had. But we also depend on stable coastlines, predictable seasons, and crops that can't easily move when the climate shifts. If the Eocene teaches us anything, it's that change this big doesn't play favorites. Even dominant species can be humbled. A personal connection. Here's a thought experiment for an American audience. Picture a road trip from Miami to Seattle. Today, that's a journey across swamps, farmland, deserts, mountains, and forests. In an iceless future, it might feel more like driving through a giant subtropical belt. Mangroves in Kansas, rainforests in Nebraska, storm-battered coastlines creeping hundreds of miles inland. That's not science fiction, it's a glimpse of what the late Eocene really was. And if we keep pushing, it could be our future too. The takeaway. The last iceless Earth tells us two things. First, climate can change drastically, given the right tectonic and atmospheric shifts. Second, when it does, life adapts but not without losses. Giants fall. Survivors reshape the world. For us, the challenge is clear. We can't stop continents from drifting or currents from flowing, but we can influence how quickly the climate shifts. The Eocene reminds us that an iceless Earth is possible, but it comes with consequences. The choice we face is whether to learn from that history or repeat it. So here's the big picture. The last time Earth was truly iceless, crocodiles sunned themselves in Antarctica, palm trees grew in Alaska, and whales hunted whales in seas swarming with giant sharks and snakes. It was a world that feels like science fiction, yet it was as real as the ground you're standing on right now. And then, in what feels like a snap of the fingers on the geologic clock, it all changed. Ice returned. Giants fell. Survivors adapted. And the world reshaped itself into the one we know today. The story of the late Eocene is more than a prehistoric curiosity, it's a warning and a lesson. Climate can change. Coastlines can vanish. The giants on top today may not be tomorrow. That leaves us with a question. If Earth could flip so dramatically before, what role will we play in shaping its future now? Will we adapt? Or will we stumble the way Basilosaurus and the brontotheres did? I'd love to hear what you think. Do you imagine a future where palm trees grow in Chicago and crocodiles swim in New York Harbor? Or do you think humanity will steer a different course? Let me know in the comments below. If you enjoyed this journey into deep time, don't forget to hit that like button, share this video with your friends, and subscribe to the channel so you don't miss the next adventure into Earth's forgotten past. Every click helps keep this channel alive, and every share helps bring more people into the conversation. Because the past isn't just history, it's a map of where we might be headed. Thanks for watching, and until next time, stay curious.